Welcome to the LIGEN Urgent Computing Workflow demo. The following recording shows demo workflow that runs LIGEN calculations in parallel on these 4 HPC locations: LUMI Supercomputer, Carolina IT4 Innovations Cluster, Leonardo Seneca Cluster, and E4 Cluster. For each HPC location, a separate input dataset was created for the LIGEN computation. With this setup, we want to demonstrate that splitting the dataset and computing different parts of it on each HPC location is possible. This approach helps to balance the usage of the clusters and speed up the calculation. Each dataset was uploaded through the LEXIS portal interface. In the recording, you can see the process of uploading the dataset that will be chosen for staging at the E4 HPC location. It is possible to upload the compressed dataset through the LEXIS portal. In the user interface, there is option to uncompress the dataset at the destination where it will be staged. Let's now move on to the configuration and execution of the workflow with LIGEN computation on 4 HPC locations. On the left side of the screen recording, you can see the LEXIS portal interface where the workflow configuration takes place. For example, this is where you select the partition, define resource allocation, and manage the datasets that will be staged on the individual HPC locations. For this demo, 4 different datasets were chosen. And on the right side of the view, you can see terminals with the connections to the LUMI and Carolina HPC locations. The urgent computing workflow for LIGEN has been executed. The directed acyclic graph displayed on the LEXIS portal screen represents this workflow. For each HPC location, the workflow begins with creating the working directory in the HPC project Scratch storage, followed by staging the chosen input dataset to the working directory of the HPC job. On the left side of the screen in LEXIS portal, you can see the current workflow status for each defined task, represented by graph nodes. A green border around a node indicates that the task was successfully executed, and for example, blue color indicates that the task is in progress. The staging phase of the input dataset workflow is nearing completion for all 4 designated HPC locations. A listing of the working directory in the SSH-connected terminal on Carolina, positioned at the bottom right of the screen, confirms the dataset staging process is finished and the dataset is ready for computation. Similarly, the terminal at the top right, connected to LUMI, shows the same status. Actual LIGEN computation has begun, HyperQ server was initiated on every HPC location, and the HyperQ workers have been deployed. In the bottom right window with the Carolina SSH connection, you can observe the HyperQ server dashboard. HyperQ dynamically groups tasks into Slurm jobs and distributes them to fully utilize the allocated nodes. For this demo, the computation allocation for the Carolina location was configured on 2 nodes. As you can see in the dashboard, on the Carolina, there were 2 HyperQ workers deployed, one for each allocated 128 CPUs node, and the utilization of the node is approaching the maximum possible utilization for each node. The computation phase of the workflow is completed for all 4 HPC locations. LEXIS now transfers the outputs of the computations to the iRODS. In the both terminals, you can see listing of the output directories of the computations. Each computation on each location produced one CSV file named by HPC location where was output computed. After the computations are done and output files from all the HPC locations are transferred to the iRODS, post-processing part of the workflow is executed. Post-processing phase starts with the input files staging. The input of the post-processing job consists of all of the outputs from the computation stage, which was finished before the post-processing stage started. For the post-processing job, Carolina location was selected for this demo, as you can see in the right side of the screen. All input data files were staged on the scratch storage on Carolina. Then, the post-processing script is executed. This post-processing script takes all the input CSV files from the computation phase of the workflow and creates one CSV file as output of the post-processing. The urgent LIGEN computation workflow execution is done. Results from all of the computations which were executed at 4 HPC locations are available to download from the LEXIS portal. Also, the final result, which was computed in the post-processing stage of the workflow, is also available to be downloaded from the portal, or showed directly in the LEXIS portal, as you can see in the recording. The demonstration now continues with the showcase of a similarly defined urgent computing workflow designed to be fault-tolerant against unexpected unavailability of services, entire HPC locations, or computation failures at any HPC location. This workflow is structured to succeed and perform post-processing with the data from at least one successfully computed result. The goal of this workflow configuration is to deliver all possible results at any given moment, considering potential unexpected outages, service unavailability, and data transmission issues. In the recording you're watching, you can now see the configuration of a fault-tolerant workflow in LEXIS portal. As in the previous demonstration, each HPC location has assigned one input dataset. This workflow has special checkpoints defined where the status of tasks executed at each HPC location is monitored. The workflow advances past these checkpoints only if the computation is successful at least at one HPC location. Specifically, this means that this workflow will be successful if 4, 3, 2, or even just one computation result is available, which will then be used as input for post-processing phase. As you can see, the workflow has been initiated, and in the directed acyclic graph, which consists of nodes representing individual workflow tasks, the nodes at one HPC location are marked as red or orange. This indicates a failure or a cascading skip of tasks within the defined workflow in case of failure of crucial task. We have now reached the moment when computations were successfully completed on 3 out of 4 HPC locations within the workflow. Subsequently, the computed results CSV files were transferred into IRODs. In the next step, a special task was used to verify how many computations had been completed. Since the criteria for continuation were satisfied, the workflow proceeds to the post-processing phase with 3 input files from the computations. The data staging phase for the post-processing job was initiated, and all available computation results were staged at one of the HPC locations where the post-processing job will be submitted. You can observe that 3 input files were staged, while the 4th data file is unavailable, possibly due to an outage at one HPC location or a different service, computation, or network failure. Following the data staging procedure, another verification task was executed to validate that all available datasets from the successful computations were transferred to the scratch storage on the HPC system where post-processing will be performed. The post-processing job was submitted, and subsequently an output CSV file was generated by the post-processing script. This final output file was then transferred to IRODs and is available to be downloaded or opened in the LEXIS portal. Importantly, the workflow succeeded despite an unexpected failure of computation on one HPC system. The failed computation can be resubmitted, for example, on a different HPC system if necessary and feasible. However, the key message of this demonstration is that in urgent computation, it is crucial to generate some outputs that can be refined or completed later, rather than having no output at all. An urgent computation workflow can also be used when the input dataset for all HPC locations is the same, allowing to retrieve the first successfully computed result or validate correctness of the results against all successfully computed results from different HPC systems, depends on the target of the usage and use case. This is the end of LIGEN Urgent Computing Workflow demo. Thank you for your attention.